Thanks for saying yes to this, mate. Really appreciate it. I've known about your work for God now, like almost. When CJDNS is about 10 years old now, isn't it? A little bit. No, not as old. Is it?
Let's see, 2021, 2011. Yeah. I mean, in 2011, it was. I think it went live the 1st of 2012, the first day of 2012. So. Yeah, I mean, the software existed in 2011, just didn't work.
Oh, well, okay. Because I remember with hacking with Chris Double, a New Zealand guy, and I think it was with Chris. I can't remember who, but we set up this. We set up a few instances of CJDNS, and we actually got it to work. And I don't know. It was just like it was like a bit of a mind-bending moment for me that yeah. You know, like, oh my God, I'm sending a packet over the internet, but it's like it's not, you know what I mean? It's a nice overlay going on there. It was the first time I sort of like this thought process sort of entered into my mind, and I'm very curious to know like, how did you get into this? What is CJDNS? What's the story? Morning Glory.
Yeah, absolutely. So, I mean, I grew up in a rural area in Massachusetts, US, and where I grew up, the internet was just slow, and you had to go through the telephone to get to the internet, and it took a really long time before even DSL got run to that area, and so back as far as like my teenage years, I was thinking about the idea that internet could be something that people did themselves. And, we had mountains and you could see the neighbors across the mountain. And so, you would have a lot of time to wait for pages to load and a lot of time to think about how this could be done better. And, just thinking this through that, we could run our own internet, but, you run into a couple problems. And one of them is privacy, and one of them is security. And the privacy problem is kind of huge once you get rid of a centralized ISP. I mean, if you've got a big centralized ISP, then you can kind of amortize the privacy problem and just say, well, there's this one company, they can see everything we're doing, but it's just one. And it's a problem, but it's not a huge problem. People say it's a huge problem, but it's on a different magnitude than your neighbor can see what you're doing on the internet. And so, once everybody can see everything, then the problem becomes like unacceptably huge, and it just prevents these kinds of networks from getting off the ground. And the other problem is security. And security is, well, unfortunately, networks, the way they work is typically the computers trust each other. And that's not really a problem for the internet because the regular computers like yours and mine aren't allowed to talk to routers. The routers are the ones that trust each other. And, our computers are saying our computers are not allowed to talk to those routers. And but if they were, then you'd potentially be able to just send, you'd be able to say, hi, I'm Google. And they would all just accept that. And then all of the traffic meant for Google would go to you, and people wouldn't be able to reach Google, or worse, you might be able to impersonate Google or something like that. So this property of particularly the denial of service, you can just take out, typically you can just take out a network. And there's a couple exceptions to that. One of them is BGP, which is the routing protocol used to route the internet, and that one is pretty secure against this. Not perfect, but it's pretty good. It's one of the best, and it's good because you've got different companies interfacing with each other through this protocol, and that it's good enough for that. So BGP is pretty good. All the mesh networking protocols out there are pretty bad. Typically, if there's one node in that network that just is run by an adversary, you're going to have disaster. So CJDNS was designed with the intent that if there's a node that's evil, we want to limit what it can do. We want to try to put limits on the amount of damage that it can do to the network. We want to try to reason about that, whereas other networks just say that's not a threat model. So that's kind of the origins of it. I'm rambling a bit, and you can maybe give me another question.
No. I mean, no. I encourage the rambling. You see,
Okay.
it finds the sort of like the cracks in the ledge which you can jam your fingers in and start to climb up further. Now, but I mean, okay, so like CJDNS 10 years ago, you must have been about say 30.
10 years ago, I was about 21.
21. Oh wow. Okay.
Or no, 23. Yeah, 23. I think I was 20 because
that's
yeah,
kind of
that's right.
kind of an ambitious age to write a new internet protocol, hey?
Yeah, I guess so. I'm an ambitious person.
Okay. So I mean, so what? You just looked at this and you thought, okay, fuck it, I'm gonna write this stuff myself.
Every morning, and this goes back even further than that. I mean, my teenage years. Every morning, I was getting up and drinking my coffee, and I was thinking about this problem, which I call it the BGP problem, and really, it's routing table bloat. And a lot of people don't know about this problem. There's a much more popular problem, which is that we're supposed to be running out of IP4 addresses, and we are. But there's another problem that isn't solved by IPv6. So just to give people a little bit of background, there's two internet protocols. One is called IPv4 and one is called IPv6. And most of the internet actually runs over IPv4. But unfortunately, there's only about 4 billion IP addresses in the IPv4 space. And we are officially out of addresses. They're not all being used, but they've all been allocated to someone or other. So IPv6 has, IPv4 has 32-bit addresses. IPv6 has 128-bit addresses, and there's so many of them that we believe will never run out. Now, the bigger problem is that, and the IPv6 doesn't solve this, is that every time you start a new ISP, so every time you start a new network provider of some sort, you have your own block of addresses. You say, I have 32 addresses, or I have 256 addresses, whatever number of addresses you have. And then you announce that block to the routers on the internet and say, hi, I'm here. These are my addresses. And if you have anything to send to any of these addresses, I'm the one handling it. And every one of those announcements adds to the global routing table. And the problem is that ISPs want to get blocks of addresses, and they never want to give them up once they have them, because it's kind of like property. And once
it's revenue generating, isn't it? Or potentially revenue generating.
Yeah. And their IP4 addresses are now really expensive even. So nobody wants to give them up. And nobody likes putting together groups of addresses into bigger groups. So if you have a group of contiguous addresses, so this sequential numbers, then you could just group them together as a larger group. But typically ISPs don't really do that. They tend to break down into smaller and smaller and smaller groups, and they just never put them back together again. And so the routing table gets bigger and bigger and bigger. And we've had routers. There was a day a few years, 2014, I think it was 512K day. You can look it up on the internet. It was a day that the number of prefixes of announced routes on the internet crossed over 512,000. And a whole bunch of routers crashed all at the same time because they just ran out of memory. And now, everybody knew this, or everybody kind of knew this was going to happen.
A Y2K problem kind of thing.
Yeah, but except for the ISPs who had those routers, it's like the people who are watching were like, hey, the routers are going to crash, and the ISPs that had them were like kind of asleep, and then the routers crashed, and then they rushed out a patch, and big parts of the internet were out for about half a day because of this problem, and this is coming again. There was 700. So they rushed a patch, and they basically just took some memory space away from the IP6 address, and they gave that to IP4. But it's coming again. We're gonna run out of space again, and then the routers have to be upgraded. And these are perfectly functional routers, but they are not able to switch the more routes that exist on the internet. So anyway, I was thinking about this problem, like how could this be solved as a fundamental issue? Like how could it just solve this forever? And what I came back to what's known as source routing, and this was something that was studied in the early 90s, but basically it didn't really go anywhere. Source routing, you give the sender of the packet, so just for people's information, data sent across the internet is broken up into little messages that are called packets. And it's a bit like sending mail. You put an address on the message and you send it, and then the person at the other end takes all the letters and puts them all back together to get what you wanted to send. So as we're having this video call here, my computer is sending a stream of packets, one after the other, over to the server at Jitsi. Anyway, the idea of source routing is that you would put, instead of the address of the packet where somehow 123 Oak Lane or something, you would put the directions to get there. Now, those of us who are the pre-GPS generation know the difference between address and directions. I think a lot of people don't just say, what is directions? But we probably, you drive, you remember when you used to, figure out that you just take the address and go on the map, and then you'd write down the left and the right turns that you had to make, and then you'd read the directions when you're in the car. So anyway, this is the idea of source routing, is that you put the exact directions that the packet has to take. And the upside of the downside, well, let's say the downside of that is if there's a roadblock, then you have a problem. You can't just route around that. You have to either send that packet back where it came from, or you have to drop it and then send another one with corrected directions. The upside of that is that at each router along its path from its source to destination, you do very little computing. And that's really important because the routers are having to switch billions of packets per second. And I don't know if it's billions, but some of them are probably switching billions. They're switching a very large amount of packets per second. And that is requiring them to do this computation of, based on this destination address, which road is the best one to take next. And that's the kind of the computation that your GPS does, but you're having to do that like at least millions of times per second, and that's leading to very expensive hardware and that's the things that are, these routers are getting overloaded with too many routes in the internet, and that's what's leading to, and nobody wants to replace them because they're so expensive. So this source routing, this was the change of CJDNS, and one of the unique properties of CJDNS was that the route in CJDNS, as you go forward through the network, it takes apart the route one step at a time, the forward route, and it builds up a backward route in the packet header. So at any point along there, if there's a roadblock, you can actually turn the packet header around in reverse, and that gives you the path back to where the packet came from. That's the unique property of CJDNS. And with that unique property, we're able to solve a big problem with source routing, which is you get into a corner and then you have no way back and you have no way forward and you don't know what to do with the thing. All you can do is drop it and hope that the sender figures out that there's something wrong. And so solving that problem opened up a kind of a world of possibilities, because we could do source routing, and when there was a problem, we could just send it back, and then the sender would be able to figure out what to do with it.
Oh, I see. And that would be like, every node you would see like, okay, turn left, go, turn right, turn left, turn right, and then eventually you arrive at the destination, and then the end user sees the hello world text message, basically. And now you mentioned that this source routing is a little bit not used that much now. What's your opinion on it now?
So right now, basically there was research around it in the early 90s, but it didn't go that far because routers just started to get really fast. And because prefix lookups, that's the thing of figuring out what direction to take at each hop along the path. That the prefix lookups, just because chips got so much faster so quickly, they didn't really need source routing, and they didn't have this ability to turn the route around backwards and send it back to where it came from. So without having that technology and the additional complexity of source routing, it just wasn't worth it. It was easier to do the prefix lookup at each hop along the path, and then they used BGP and that worked. But the problem is that this doesn't totally scale it doesn't scale as well as source routing does. If you do source routing, you can have what we call a switch, and the switch can just switch traffic as fast as the lines can carry that traffic. You can basically switch it because you're not really doing anything in that switch. You're just looking at the packet and saying, where do you want to go? And then sending it the way that it says to go. However, there's another issue with this, and that's denial of service attacks, because you can attack a source routed network by sending a packet and telling that packet you should go around and around and around in a circle, and then you're able to amplify a denial of service attack. But that's a problem of setting up good quality of service and traffic balancing, throttling. And that's something else that the internet doesn't do and pays dearly for it. So the fact is, because people said, okay, that's a problem with source routing, but it's also a problem with the internet as it is today, and denial of service is a huge issue, and it actually pushes everybody onto centralized platforms, because if you're not on a major company like Amazon or whatever, then you risk to have your website shut down by botnet attacking you. So these are the things that we're working to solve.
Yeah. TCP/IP acts as a almost like a focal point. It's like inherent part of the protocol, where you can take over a botnet and thank you, network, for helping us destroy the competitor. Yeah. So I wouldn't be surprised if it is in fact Facebook or Twitter that are actually DDoSing the competitors.
Well, that's always the old conspiracy theory. That the anti-DDoS companies and we'll take care of you, but it would be a shame if something were to happen to your nice website, kind of thing.
Yeah, like the antivirus companies. Yeah, exactly. Yeah.
Of course.
So but when I went to the CJDNS repository, I noticed that most of it is assembly. Good God, man. What's the story there?
The reason for that is because it's based on the NaCl encryption library, and we just embedded the library. We just vendored the code, dropped it into the code base, because that way we get full control over versioning. Nothing's no surprises. So yeah, we that assembly is there, but it's because of copy paste.
Yeah, my mate took one look at it and he's like, these guys have just vended NaCl, just straight up vended it.
Yeah, exactly. And at the time, so and people kind of criticize that. You're like, why are you not using live sodium? Well, guess what? Live sodium didn't exist when CJDNS started.
Sure.
So there were a lot of things that didn't exist when we got started. So it's kind of, you need to evaluate the decisions that were made in the context of the time when they were made, because a lot of things didn't exist that do now. And actually, we're working toward rewriting a lot of parts of this code into Rust, because that gives us a lot more. It makes me able to sleep at night, because we don't have the memory corruption issues and the attacks that you have when you're in a non-memory safe language.
Exactly the same decision for my choice of language too. It's like, I don't know why people would choose to use C or C++ nowadays if it's a fresh project like that. It's like, okay, let's look for the foot guns, man. Let's just bring those foot guns back,
Yeah.
And are you going to be re-implementing CJDNS again using the source routing approach? Or
or have source
you got
routing is it's in CJDNS now. I mean, and the custom.
I mean the new Rust implementation.
It will be ported to Rust a bit at a time. Like we're not trying to pause all development until it's all in Rust. But new development is happening in Rust primarily, and we're heading in the direction of a lot of new development, and that's because of Packet, which is all about creating bandwidth leases, and the bandwidth leases is where we bring the QoS and the load balancing back into the mix.
So Packet is PKT, PacketNet, or what is it? What's this project name? And go into that.
Yeah, pkt.cache is the website, and even more fun is pkt.chat, where you can hang out with us and talk about it. But the idea of Packet is, we built CJDNS, but networks that can't pay for themselves will forever be hobby projects. That's, and it's a lot of fun to do hobby projects, but at some point, we really did answer a lot of the questions that we had with how CJDNS should be designed, how it should work. And once we felt like, we had the answers, then we could go toward a more industrialization phase. And this all happened at the same time as the Lightning Network on the Bitcoin Lightning Network got kind of off the ground. And Lightning Network is really the only thing that scales to the size that we need to go in terms of being able to transact. So that's when we decided to get back into it, and we kicked off the Packet project as a way to take this technology to the industrialization phase. So there were a couple things that changed along the way too, and one of them is that we initially used fully decentralized routing with DHT, and we migrated. We learned a lot about DHT routing, but we ended up migrating to a semi-centralized system of basically supernodes. And the concept of a supernode, or what we call a route server, is that you delegate your routing decisions to somebody who knows what they're doing. And
they have an overview of the network.
Yeah. And they also know what they're doing in terms of their technical. It's a person running that device, running that machine, and they can make informed decisions. And because when you're just doing like an overlay network and you're just having fun, it's okay if that network stops working, but it's not okay if you're using this for your primary internet connection and it stops working. You need somebody to call. And that was one of our lasting problems with this decentralized routing is, number one, you need somebody to call. And number two, the person who you call needs to be able to get in the mix and fix things. And when we had this fully decentralized routing, I mean, you might call somebody, but they're just going to say, it's the DHT. And that's not an answer. When you're paying money for your real internet that you need in order to, right now with the coronavirus and everything, you need it to get to work. And we can't have not being able to call somebody and have them fix it. So we switched from this fully decentralized system to what I call choice of kings decentralization. And choice of kings means you can choose what kingdom you're going to be part of, and you delegate that authority to somebody, but you choose who that somebody is, so you don't have this political centralization that causes us a bad rap for centralization, but you still have somebody that you can call and get the thing fixed. So that's where we're going, is to this world where it's a bit like a DNS lookup. So for people who don't know DNS, when you type into your browser, Jitsi or whatever, that name needs to be looked up and converted to an IP address in order to be sent over the internet. And the concept here is that we're not going to just convert it to an IP address. We're going to convert it to the route to get there. So,
Oh, wait, you just blew my mind there. Oh shit. Okay, yeah, I've just got like okay, how do I even start? Okay, I'll let you continue talking.
Yeah. I mean, IP addresses are not really useful for a human. Humans use names. We don't use IP addresses. And they're not really useful for routing either. For computers don't really want IP addresses. What they want is the directions to get there. They want the route. So
what does it look like then? What does the conversion look like?
Well, you're making a request to what we call a route server, and that server is, you can send it a request for an IP address or a request for a name, and then it can convert that name into the path that you need to get from source to destination.
And the path would be from IP address to IP address?
No, it's basically saying take a left and take a right. Early source routing used it was every IP address in a list, and that made the route very big because IP addresses are big. But if you're just saying, take the next fourth interface and then take the third interface and then take the second interface, then it's very small, and that's part of the compact source routing of CJDNS.
So each node would have, for a moment, let's imagine we have a graph in front of us, and there are 5 nodes, and they're connected 1, 2, 3, 4, 5. The objective is to get from node 1 to node 5, and as a result, you say, okay, I want CJD, and then what will happen is that you will have a series of 4 1s.
Yeah,
that
basically.
Would appear to you. Because each node has only got one edge.
Right.
That's correct. Okay, so now 2. If you were to 2 nodes, 2 edges. Sorry, 2 edges. And if you were to introduce an offshoot on each one of those things, then depending on which one, so that means this network is also kind of stateful. Right, because you can change the interfaces. Maybe I've got a laser interface over here, and then it goes down, or I choose to set up something else on another interface, and then therefore that information would need to be communicated to the third party, the routing server.
Yep, and that's how it works. When your nodes are constantly sending messages every 30 seconds or every minute, they're sending a message to their route server. So that message is signed, and it's signed using that node's key, which is its identity. And that message, it's got a timestamp, and it says what all of the connections and interfaces are, and it also says link state. And then the route servers are able to communicate those messages amongst one another. And the logic here is that route servers are going to be in data centers, and data centers have really fat pipes between one another. So the people running these route servers are not going to have much trouble getting all of this linked state information from one to the other, whereas it would be much more difficult to flood it out over the whole network. Now, this will not scale at some point because we're doing linked state updates on the entire internet. That's not going to work eventually, but at some point, route servers are going to be able to say, I'm interested in these links and I'm not interested in those. And so you tell me about these ones, but not those ones, and we'll be good.
Okay, so it's hierarchical then. At that point, you introduce the concept of hierarchy into your routing. Is that correct?
We will. Basically, we will, but we can do it without changing the network itself. That will be a change made in the route servers and the what we call cloud ISPs, the companies. So to get a little bit into how Packet evolves with this, we have this concept of cloud ISP, which is basically it's a tech company, and it's a service company. It doesn't own any infrastructure of its own, and that's very important because we're separating. So the concept of Packet, the fundamental concept, we're decoupling the role of infrastructure operator, so the person who runs the fiber, that puts up the antenna, etc., from the role of network operator, the person who invoices, the person who allocates IP addresses and handles where the traffic goes in that network. So we're decoupling those two roles, but keeping them both existing. Those are both roles that are very important in an ISP, but by decoupling them, we allow a lot more competition because you or I or anybody can just put an antenna on a roof, and we're off to the races. We don't need to be involved in billing and customer service and abuse handling or reports. We've got, basically it's a VPN company, VPN on steroids, you might call it, but it's a cloud ISP and it gets you on the internet via the mesh network. So anyway, that was a little digression into what we're doing with Packet, but that gives you an understanding of how the route server is, we'll need to upgrade the software of the route server, but that's a pure software upgrade that's going to be made by companies, and we don't need to upgrade all the hardware of the network.
Oh, I understand. Yeah. Okay. All right. Okay. Yeah, lots of information there. No. I love this. I love this area. This domain is of keen interest to me. So I'm very curious to know, like, as much as I can about the operation, how you wish to go about, the end vision, so to say. Talking about the end vision, what is the vision?
I think the vision is that we should not need to have big centralized ISPs charging us lots of money for internet access and limiting our speech and these types of things. You should be able to have your own internet. And if you're a tech enthusiast in your local community, maybe you bring in the fiber to that community, you put an antenna on your roof, and you're now serving internet to all the people around you. And this might not happen so fast in places like Europe and America and Asia. Well, America probably will because internet there is pretty bad. But think about places like rural areas in South America.
The Philippines. The Philippines, the islands of in the Philippines, it's pretty rough out there.
Yeah. I would spend some time in Guatemala, and there were people just running Wi-Fi long shots to get internet from one place to another because the quality of the cable internet is just not that great. So, you get into these other places, this is about getting the next billion people on the internet, and it's great to provide a better service to the people who have it now, but it's even greater to provide any kind of service at all to the people who don't. What was I going to say? In Guatemala, Uber was a huge thing because you had before that you had these little tuk-tuk cars, and they're basically a modified motorcycle with two wheels in the back, and they would charge, 20 quetzali to take you across town. And this was maybe like, I'm trying to remember, I think it was around like $5. But then Uber came into that community, and these people were driving, this was more amateur people, and they were driving you around for like $250 in a nice car with air conditioning, and so the quality just shot up. And because there was this aspect of reputation and so on, this just having this tech company from Silicon Valley to organize people in these communities provided a much higher quality of service. Now, that's kind of what we're trying to do with Packet, but we don't want to have this one monopoly the way Uber is, where everybody just uses the Uber app and the Uber controls everything. What we're trying to do is have a decentralized system where there are multiple Ubers, and these multiple Ubers are buying the bandwidth leases from the people who are running the infrastructure.
From the data centers, right?
Yes, and individuals, people, anybody who wants to put an antenna on their roof, point a long shot, whatever, run a fiber into that community, because that's where you get internet into a community, is using, you got to be somebody that lives there typically, or somebody has to come in with a truck, but that's expensive, and that's where you have all this friction. And just having somebody who lives there do it, that's much cheaper and easier. So that's what we're trying to do, but instead of having this one company the way Uber works, we're looking to do a decentralized bandwidth marketplace. And the concept of decentralized bandwidth marketplace is that you put this antenna up on your roof, and it sits there, and it just starts selling. As soon as it makes a connection, it says, okay, I have this much bandwidth, I'm going to sell future leases on that bandwidth. And so this is kind of like an NFT for bandwidth. But it's a time limited bandwidth lease that you're then selling off into the decentralized bandwidth marketplace to be picked up by these cloud ISPs, who then use it to knit together their own virtual networks that run on top of the mesh.
Okay, you need to deconstruct that. Let's go into that a little bit deeper. No, I mean, it's okay. Yeah.
I've had a lot of time to think about this. So
but this is
a lot of detail.
No, but this is the exact thing. It's like sometimes you as the founder, as the creator, you go very deep into these things, and many times you don't actually communicate them with the outside world, or the people that you're socializing with have no fucking clue what you're talking about. But whereas I like the subject now. Okay, so can you unpack that a little bit more? Can you go into more detail about what you mean about that?
Yeah. So let me try to just give you a scenario. You go and you put an antenna. Let's say that you have an internet connection. You bought a business internet connection that you're allowed to do anything with that internet connection. All right, great. You're paying through the nose for it. So you're going to put a Wi-Fi antenna that your neighbors are able to access that internet. And instead of just letting people connect to your internet like with a captive portal, or they just enter, telling your neighbors the password and asking them to chip in to help pay for that, you just put that antenna and you're done. That's all you do. And that antenna, that device goes into the bandwidth marketplace, and it just starts selling bandwidth. But you're not selling, so you're making packet, you're making cryptocurrency for your bandwidth, for your excess bandwidth, but you're not selling it to your neighbors. We're not expecting grandma to be managing a crypto wallet in order to just get on the network. That's too much friction. Maybe she wants to. There are cool grandmas that are into cryptocurrency, figuring out stuff, but we don't want to. We don't want to expect that out of everybody. We want to make it something anybody can just get into. So what your device is actually selling, where your device is actually selling that internet, is to cloud ISPs. They're bidding on those bandwidth leases on that device, and it might be bidding very low price, but they're able to grab those up, and then once they have it, then they're able to provide internet access to your neighbor.
So they'll route requests for that. So they say, okay, I will control this, and that means I will send and receive data to this block. I now have an agreement with all the other cloud ISPs that you guys don't fuck with this little area. I own it for a limited amount of time.
Yeah, and
okay. Is that right?
Your device is going to be enforcing that. So they're able to send a request to your device saying, "Hey, I'm here. You need to please configure." And your device is going to say, "Okay, there's the configuration." And you've got multiple cloud ISPs having this sort of residency inside of your router that are able to do limited configuration of that routing device. And you, the owner of the router, you don't need to do anything. You just put it up, and as long as it keeps working and functioning, you keep making packet with that device.
So now, say I'm a nefarious owner of this antenna, and I assume that the source code that I'm running would be open.
Yeah.
Okay. Now, surely I could go into that code and fiddle with it, so that I can say, okay, just one cloud ISP just ain't enough for me. I'm a promiscuous router.
Right. So
I got many partners.
yeah, absolutely. So normally, you're probably going to have a lot anyway. Like that's accepted, that you can break up your bandwidth into 10 slices or whatever, and then you can sell those 10 slices to 10 different ISPs, cloud ISPs. But where I think that you're getting at is, what if you say, I have a gigabit of bandwidth, even though you don't, or you set up a router and it has all this bandwidth, and then you turn it off, and you sell all the tokens to all the cloud ISPs, and then you turn the router off. And that's something that we can't really solve. That's just a fundamental problem of, if you're selling a future of something and then you don't deliver. But we don't need to solve that from a technical perspective. All we need to do is do a little bit of reputation. It's a market. There's reputation. I've been running that thing for a long time. That you're going to command better prices. But also, if you don't have the reputation, then a cloud ISP that believes in you early on, they can just grab up all of those bandwidth leases at a lower price. So by making it very human, this is the old thing. It's like when we have financial markets, they actually work really well. We do like energy trading. We trade everything. And financial markets are one of the things that we've gotten kind of more or less right. And we'd be foolish to try to change this and do something different with it than the thing that we know. And that's a bit my criticism of a lot of other incentivized mesh projects, is that maybe that you're setting up a system where your neighbor connects and then they send you a micro penny every time that they whatever. Number one, your neighbor has to have a crypto wallet in order to do that. But number two is that let's just use two things that we already know work. And one of them is network operators. Just take the network operator, put them in a cloud ISP so that they can continue to operate the network, but they're not owning the infrastructure as a monopoly. And the other thing is financial markets. We don't know what the value is of bandwidth between my house and my neighbor's house. Let's let a financial market figure that out for us.
Okay, this is nice. I love this. I love this idea. I've had very similar thoughts along the way. Now, okay, so essentially you have three entities. You've got the network operator, which are the guys running around with the antenna and whatnot. Then you've got your cloud ISPs, which would be the network operator. Then also you've got the exchange operator, or the financial market operator. Is that correct?
So you've got the infrastructure operator, and that's the guy with the antenna.
Okay.
So that's
terminology. Got to get the terminology right. Infrastructure operator.
yeah, in your local community.
Yeah.
And then you've got the cloud ISP, and that's some wizard in Silicon Valley or wherever. It's a startup, it's a tech company. They don't own any infrastructure. They're kind of doing what Uber is doing, but there's a lot of them, so it's competitive. And people can choose whichever one they want in order to get them on the network.
Hang about. Stop. Careful. So, are you saying they're doing what Uber is doing, as in a user-facing application, any application?
Yeah, I mean they're going to be the ones making or white labeling the software that's going to run on your phone and on your computer in order to get you on the network. They're going to be your point of contact. And if anything goes wrong, those are the ones you're talking to. Okay. Think about it like you've got a phone plan with SIM card, and you go into another country and you're roaming, and when you're roaming, your ISP or your phone company is paying the local phone company some money for you to use that network. It's the same concept. It's just that the phone company, the one that that gives you your SIM card, doesn't own any actual infrastructure, and everybody's always roaming all the time.
Right. Okay. And then there's the third party, which would be the exchange operator.
We don't need. We're not trying to make exchanges here.
I mean, it's a financial market, right? I mean, you have to place bids and orders somewhere.
Yeah. No, we can do that fully decentralized, and that's a key aspect of this. Yeah, I mean, the DEX stuff has just been starting to get off the ground, decentralized exchanges, but most DEXs are semi-centralized, and what we're calling the decentralized bandwidth marketplace is fully decentralized, just as people trading Pokemon cards under a tree is fully decentralized. The way that decentralized marketplace can work is based on a part of the Lightning Network. It's used in the Lightning Network called a hash time lock contract.
HTLC,
Exactly. And for people who don't know what it is, if you know databases, it's a two-stage commit. You basically pre-commit to doing something, and then you say, if you have the hash of a secret, and you say, this is the hash. If the secret's revealed, I will pay you 1 Bitcoin. And you say, if the secret is revealed, I will pay you 100 Monero, whatever. And then actually, Monero doesn't work with HTLCs because it's a different chain, but you get the idea. And then once those two pre-commits are done, then we reveal the secret, and that causes both of those transactions to trigger, and there's no way out of it then for either party. So having that functionality of a trustless transaction means that we don't really need a centralized exchange in any capacity. And that's where we're going. You're just going to trade the wallet.
Yeah, there's also one aspect to the hash time lock contract is that if the initial condition is not met, then after a certain time period has expired, then you get your Bitcoin back.
Exactly. So if the secret doesn't get revealed, then all our money goes back to us, and that transaction just fails.
Right. Okay. Now, wow, there's still quite a lot to unpack here. You've thought a lot about this, I can tell.
I've had a lot of time to think about it. Yeah. And I also got to watch a lot of other projects and how they approached the problem, and I could see, what worked and what didn't work. And
so what have you learned?
Well, I learned that decentralized routing doesn't really work because you don't have somebody to call to fix the problem. And I also learned that any kind of system which requires everybody to get on a crypto wallet is not really going to work, because people adopt things at different paces, and if you're trying to, and also really anything that allows a person to potentially lose a lot of money. This was one of the problems with these decentralized incentivized meshnet projects, was that you could potentially watch a whole bunch of movies, and then all of a sudden you just spent your entire month's internet bill in one day. and you might not even know it. You could wipe out your wallet, and like they could build in technology to make that more difficult, make that harder. But at the end of the day, not having just this one company that you just pay your regular $20 a month for and make it their problem, it makes it very difficult for an ordinary person to adopt.
Okay, so the main sort of lessons are like, rubber meets the road kind of thing, the actual adoption issues, in the sense that. So in your system, you're talking about an exchange where, I mean, not an exchange, where a marketplace basically where people the infrastructure can sell their stuff. And how do they get paid then? You said there's no crypto wallet associated with it, right?
Oh, okay. So, I mean, if you're operating infrastructure, you're one of the people, you put the antenna on your roof, you're going to be earning packet with that antenna. So, that thing will have a wallet, and you will be making income as packet. And then
okay, so it will have a crypto wallet with it, right? But just now you said one of the lessons that you learned was that people won't
make people have crypto wallets. The difference here is that you've got a crypto wallet, but you're just earning with that wallet, and so it's a lot easier to deal with something where you're just earning those coins, and you can trade them away, sell them, do whatever. But we don't have a situation where, number one, you don't expect somebody, if somebody knows how to put an antenna on the roof, then figuring out how to earn their remuneration for that with a crypto wallet is not a big ask. But for somebody who just is trying to figure out their iPhone, that then asking them to have a crypto wallet, that is a big ask. So that's the difference here, is that an ordinary user who doesn't run any infrastructure, like, we want that to be as smooth as possible for them. But once you get to the point where you're putting up your own infrastructure, it can be a little bit harder. But remember, we're not asking them to spend any cryptocurrency. They're never having to spend. And so the complexity of, did you spend your entire month budget in an hour, or how many micro pennies did that packet cost, or how much did it cost to have that video call? And that all of that stuff just goes away because you're never having to pay with cryptocurrency. You're just receiving it.
Okay. So that would be the infrastructure operator who would be receiving it, right?
Exactly.
And now then you get your end users. That's me, a dumbass guy who knows nothing about technology. Dumbass. I mean, yes, I'm dumbass. and
no, I believe you'll be the infrastructure operator, but we can go with it.
So okay, no, but in this sense, now I don't know much about the technology. I'm going to, and you're the net infrastructure. I'm going to contact you and say I want a contract. I will get regular standard internet.
Yeah.
IP internet. Okay, so this is kind of like basically it's like a VPN.
Exactly. So you're going to make the contract with the cloud ISP. That's your point of contact there.
Sorry.
So you're going to download the app from the cloud ISP, and then the app, you're going to open up the map, and it's going to show you, oh yeah, your neighbor here, you've got all this Wi-Fi, and you're just going to be able to connect to any one of those. It's a bit like I don't know, people who know Comcast, Xfinity. There's different things like this, but they're all siloed into the different companies, and that's a bit what we're doing. But anybody can do it. It's completely open. It's fully decentralized.
Okay. And now, when I pay the ISP cloud ISP people, I will use anything, whatever they want
that you and they agree on. So any way that so they're going to offer you all kinds of cool offers. Maybe there'll be a free deal, a free tier, and free is actually a really important part of this, because the internet as it exists today, most of the internet goes unused. It just sits idle. And the reason is because they have to over provision, because if those links become full, then it's just going to be a disaster, because there's no quality of service, no throttling, no bandwidth control. And the way that because we're designing in this prioritization of traffic, we're able to say everybody can connect, and it can be free as long as nobody else wants to use it. So the bandwidth is sort of an ongoing auction all the time, because you don't, if this is just a political opinion of us, is that you shouldn't throw something away if somebody can make use of it. It's a bit like the grocery store is throwing away the food that they could actually give to the homeless just because it's expired. And that's what the internet does every day, is throws away bandwidth. And it's because they're not able to give access to bandwidth only if it's a spare. They can only give access. They either give access and then you might run over their limits, or they don't give access. And so you've got a lot of cases where, especially in a data center, you're buying internet from one of these internet companies, and they're giving you like only a 100 megabit connection. All their technology is running 10 gigabit, but they can only give you a 100 megabit connection because they're figuring out that based on all of the connections that they've given to all of their customers, and they have this much traffic available in their backbone, they're only able to give you 100 megabit for that price. And we can just get around that. We can say everybody can have 10 gigabit, everybody can have 100 gigabit, whatever the technology is. If we're running, fast, if everything's based on 10 gigabit, let's give everybody 10 gigabit, but you have to bid for access to to actually get that traffic from point A to point B.
I see. Okay. Now the creation of these, now the creation of these tokens,
right?
Who forges them, or who? What's the story there?
So you're talking about Packet, or you're talking about bandwidth
Packet.
leases? Okay, so Packet is it's a blockchain. It's based on Bitcoin code base. So
but this is what the infrastructure people would be paid in, right?
Yeah. It's based on the Bitcoin code base, so it's fully decentralized. There's no pre-mine. There's none of that kind of shenanigans. It's not an Ethereum token. There's no 30% given to the founders kind of stuff. And I mean, this is important because you've got a lot of projects, and it is something that you got to look for. So it's the differences between Packet and Bitcoin. It has a faster block and a faster issuance decay. It's a 1 minute block, and there's 6 billion that will be mined total, and 20% of the coins goes to what we call the network steward. And this is really important to understand because it's a little bit like a founder's fee, but it's not. A founder's fee is where every block a certain percentage goes to the founder. But with the network steward is an address that is receiving these 20% of every block, but that address can be changed by way of a proof of stake vote. And so we established the network steward as an entity that it has to work for the benefit of the network. And there's another rule that's in the consensus rules, is that any coins that are allocated to the network steward that is not spent within about 90 days, it's denominated in blocks, but it's 90 days, those coins will burn. They just stop being usable ever. And so already about 300 million coins have burned out of a total of 6 billion that will ever exist, because the network steward wasn't able to allocate them to projects quickly enough. So projects, that's getting a little bit into how the current network steward works. The current network steward, as which it's a 5-person multi-sig address, and I'm one of the people, but it has a charter, and the charter is that all of the coins will be spent for helping benefit the growth of the network as a whole. So it's very important that we have 5 different points that we use to evaluate projects. People in the community propose projects to the network steward. We do calls, and there's a call for projects, and we'll open that call, and then about 2 weeks to a month, we'll set a deadline 2 weeks to a month later, and then people have to propose projects, and then we will evaluate those. We put a budget when we do the call. Then we evaluate those projects against each other, and then try to fill out that budget with the cheapest, best projects. However, there are projects that will never be accepted, no matter how. We will burn the coins before we accept those projects, and those are projects which unfairly benefit participants of the network over others. And we're huge sticklers about this, and this very much limits what the network steward can do, because, for example, one of the things is about listing. A lot of people talk about we want to get on exchange, we want to get on exchange. The problem with using these public funds to get on exchange is it's like, why should we give those funds to that exchange instead of another exchange? And it ends up being something that we can't evaluate, that person's not making a profit, and that we're not giving a handout. It's not nepotism. So typically the network steward just only funds people building up open source software, because if you say, I'm going to build this software, this is the results that I'm going to have, this is the certain number of person months it's going to take, and this is the price that I want for it, then the network steward can say, yeah, you're not really making a profit on this. We can validate that this is a fair thing, and so therefore we can fund that. And so most of the technology that's been built to date has been funded by the network steward, and we have this super ambitious roadmap. And the roadmap, the network steward is going to be looking to fund additional projects in order to build out that roadmap. So there's that, and we can talk about that more. And the other thing is the bandwidth hard proof of work, which we can talk about that too. There's all these.
Yes, aspects. I want to talk about these things. Yes. So the bandwidth, what?
Bandwidth hard proof of work. So, the oldest proof of work.
Is this a consensus algorithm?
It's a proof of work algorithm. So it's like SHA-256. The old proof of work was double SHA-256 of Satoshi. Then, that was Bitcoin. Then you had Litecoin, which is scrypt. It's like a memory hard proof of work. You needed memory. You don't technically need memory. You could do it all with CPU, but there's a CPU memory trade-off. So if you have memory, it's a lot more efficient. And then, there was lots of other proofs of work, different things. Ethereum uses this ETH hash, which uses lots of memory. Again, it's not proof that you have the memory, because you could do that with just CPU, but it's memory hard because there's a trade-off where you can save a lot of CPU by allocating a little extra memory. And in the case of PacketCrypt, and PacketCrypt is the proof of work of Packet, the proof of work basically works. It's more efficient if everybody mines together. And if you mine collaboratively with all the other miners, then you expend much less CPU work. However, it's a real proof of work algorithm. So there's a lot of projects out there, especially the Ethereum tokens, these types of things, and we need to remind people that proof of X typically is not a proof of work algorithm. There's a lot of projects where they say proof of something, proof of coverage, proof of blah, 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 blah. Typically what they're doing is it's basically a token that's issued with a faucet. And it's, the old Bitcoin faucet where you had to do type in the CAPTCHA and then it would give you like a micro Bitcoin or whatever. Basically, you've got tokens that are issued with these types of faucets. And so you prove that you have something, and then the faucet gives you a token. The problem with these faucets is that me looking back on, they say the thing was issued in 2015, I'm looking back, okay, was that thing issued fairly? In the case of Bitcoin, in the case of Litecoin, I can look back and I can say, yeah, it was issued fairly because the person who got those Bitcoins did work for them. They made the most effort out of anybody. The work was real. We don't know who did the work, but we know the work was real. And in the case of proof of X, kind of algorithms, you look back on it, it was like, well, did the person really solve the CAPTCHA, or did they know the answer to the CAPTCHA before? Was it the founder who controlled the CAPTCHA machine and then they just made their own bot that answered the CAPTCHAs because they knew the answer? And you don't know that. That's the problem. So proof of something, it's not really proof, unfortunately. It's not proof of fair issuance. And so with PacketCrypt, it is a proof of work, and so we have provably fair issuance. You can go back to block 1 and you can see that the work was done, whereas a lot of these other things you can't. So how does PacketCrypt work? I think that's what the audience wants to hear. Basically,
as well as I do.
Yeah. Basically, there's these 2 stages to mining. First, you mine what are known as announcements. And you do CPU work, and the type of work that you do is basically the same as encrypting packets. Somebody described it as you encrypt data and send it to the other node. And that's pretty close. It's pretty much what you're doing. You're encrypting data. And the point of this encrypting is that anybody who builds an efficient PacketCrypt miner is going to also be building efficient CJDNS router. That's the idea. We wanted to reuse the R&D that goes into building PacketCrypt to build an efficient VPN CJDNS router. So that's the first stage. You create these announcements, and they're 1 kilobyte messages. They're designed to fit nicely in one packet. And then you send the announcements to somebody who mines blocks. And that's the mining of the blocks is where the actual meat and potatoes happens.
Forgive me, what does the announcement announce?
Basically nothing. It's basically garbage. There is a small payload that you can add to it, so you can use it to flag that some event has happened. There is about 40 bytes that you can use for your own purposes, but the majority of this 1 kilobyte, 1024 bytes is it's garbage that you cannot not send. And the reason why it needs to be like that is because otherwise you would basically just tell the other guy, it's kind of like this. And then they would be able to reconstruct it. So we can't do that.
But aren't you also doing a dual purpose of lubricating the entire network then?
Yeah, that's the point. Because
so there is a very good purpose for that.
Multiple purposes of R&D going into tech dev on VPN and encryption and CJDNS, plus making that if you install, so you think about all the dusty Bitcoin equipment that is no longer efficient for mining. It's just sitting there collecting dust. You see, if you see some of these mining videos where they're showing off their mining setup, and then you've got over the corner, there's all the dusty machines that are no longer efficient. Yeah. Well,
I've got one corpse underneath my bed.
So the difference is with PacketCrypt is if you're mining, you're running fiber to be able to mine more efficiently with more bandwidth, and that fiber is still useful. After you're done with mining, the fiber is still going to be usable for other purposes. That's your internet. So we're incentivizing people to build out the network in order to mine, and then that's going to be able to be reused for selling internet to their neighbors, for instance, and so on and so forth. So these announcements that they're mostly garbage data that you must send and you can't really compress, and it's very difficult to do anything other than use that bandwidth to send that data. They get sent to what are known as block miners. Typically, you've got mining pools. We've got three major mining pools right now in the network, and you can send the same announcements to all the pools, and each pool will pay you for those, and then the pools send them to their block miners, and every block miner needs as many announcements as they can get. And what they do is they do basically the same thing again. They do encryption, and they do memory lookups, and they access those announcements. They They're doing accessing of announcements in memory and encrypting and accessing and encrypting in order to find a hash that is a match. And the more announcements they have,
they're not encrypting, they're hashing then.
Oh,
cryptographic hashing.
The operation that they're doing is actually encryption, but there's a hash at the end. So the actual work is encryption. And the reason why we make it be encryption is so that anybody who builds an efficient packet crypt miner is going to have already built an efficient VPN encryption hardware, software, whatever. We wanted to recapture that value as many times as possible.
Okay. So yeah. So you want to make sure that there's a CPU there. You want to make sure that this thing is able to run a router. God damn it.
Yeah. I mean, not only, but also, like, if somebody builds an ASIC for mining, it's going to be a fantastic VPN router because it's going to be able to do encryption at scale, and it's also going to have bandwidth because it needs to interface with other devices.
That's sly. That's sly.
Thank you.
I appreciate that little Nash equilibrium going on there. That's well appreciated. Okay, keep going, and then okay. So now we've got an incentivize for like an ASIC router, a VPN router.
Yeah.
And then keep going with the packet protocol.
Well, I mean,
is that it?
Yeah, I mean, we mine the blocks. The more, so the algorithm technically is your block miner work. So that's the amount of hashes, amount of encryptions that you do per second on the block miner, multiplied by the total amount of announcement miner work. So if you take all the announcements that block miner collected, and we're typically running 50 gigabytes of announcements in memory on our block miners. That's where we are now, and we're going to go a lot further than that. We're going to be into the terabytes within a year, in my opinion. Because, look, if you're doing 10 gigabit per second of download of announcements, then, well, you're pretty well going to fill a terabyte of memory pretty quickly. So
where's the videos then? Where are you routing videos and stuff?
Videos? I mean,
hey?
We're on video now.
No. I mean, is this going over the CJDNS right now?
No, but typically it is, but it's not because my CJDNS node is not working right now. But yeah, I need to get that up and running again. But typically I'm on calls and it's going over CJDNS all the time.
Interesting. Okay. No. You're saying you're moving about like at the end of the year, you're looking at a terabyte or something. Was it 10 terabytes or a terabyte?
I think that by the end of the year, we'll be around a terabyte of memory on the block miners.
All right, but this is just encrypting and decrypting and aggregating all these announcements, right? You said that was the first type of packet that is created. And then, well, you said there's a first type. I'm assuming that there's a second type. So after the announcement, there would be?
So the announcement, I mean, it just goes to the block miners. They do the block mining using thousands, millions of announcements. And then once they mine a block, they attach a fairly small statistical proof that they had those announcements in memory at that time. And that's what goes on the blockchain. It's they need to include 4 random announcements from that group. They're not going to know which ones they have to include, and they're going to include Merkle branches to prove that those 4 announcements are part of are in fact that they had them at that time. So it's a statistical proof of having those announcements in memory without actually having to include a terabyte of data on every block in the blockchain.
Right. Okay. Now, I want to ask, just out of curiosity, why have you chosen not to go with a layer 2 type scenario, maybe built on like Taproot or and the Schnorr signatures to do this kind of thing. I believe that maybe like a layer 2 on top of Bitcoin might be able to do this.
The amount of value that we're able to extract from building our own blockchain is pretty significant. I mean, you think about it, like number one, we have the network steward. Bitcoin doesn't have an answer to funding the ecosystem development. I mean, all the wallet people they've got their hat in their hands. They're trying to figure out, like it's just tragic because you got all the open source developers that are making nothing. And then you've got these guys developing ASIC chips and they're making all the money. But those ASIC chips don't really do anything. They just do SHA-256. It's not even a useful encryption algorithm. So, the amount of things that we're able to recapture of value, that we're able to recapture the bandwidth hard proof of work, and then we're able to recapture value into the ecosystem using the network steward, which is funding, competitive grant making. It's just like it would have just taken so much longer to do this on top of Bitcoin than it is to just kick it off from the start.
Okay. All right. Yeah, I suppose. And also, yeah, that's also one thing I've noticed about the Bitcoin world is that, whereas in the Monero world, I believe that like if you come up with a proposal, the community will pitch together and support your project. But now in the Bitcoin world, it's quite different. Like I've not really heard or seen of like, the Bitcoin rich people going out and supporting infrastructure. I think probably because the problem that they're going to Bitcoin for, I mean, the solution that Bitcoin offers already solves their problem, which is, to be a store of value, and that's it. There's no need to add anything else on top of it. That's as far as people are thinking, maybe.
Yeah, I mean, it's just like based on your blockchain, it defines your community, and the community defines, what you're going to get done. I mean, Monero is a wonderful project, wonderful people involved in that. I can't say enough good about it. I mean, it gets used for nefarious purposes, and that's tragic. But I mean, the people working on it, and that's where all the R&D is happening these days. They've got the greatest proof of work, except Packet I'm gonna say Packet is the winner, but behind Packet, I mean, I think RandomX is got to be the best proof of work out there. Really focusing on general purpose CPU that anybody can access. And also the work that they're doing on trying to protect individual privacy and liberty. Great stuff. The Bitcoin community, I mean, there's a lot of great people in the Bitcoin developer community, but it's very hard for them to find any funding.
Yeah, it's a sad state of affairs, actually. But I don't know. Mind you, Bitcoin's done me well. I mean, I wouldn't have, like of all the things, Bitcoin has been the most successful for me, like, with regard to funding and whatnot. I mean, just by holding.
Yeah. That's the smartest thing you can do is just buy it. Don't lose your keys, but forget about them, please.
Yes. Now, you also mentioned that there was another what was it, token, I think there was 2 tokens, right?
So
there's a funding of
every bandwidth lease is going to be essentially an NFT, and that's something that we're working on designing our own token protocol, which we're calling Token Strike, and that's funded by the network steward again. The idea is that you just make your own little blockchain, and everybody has their own blockchain. You sign your blocks. You're the issuer, So, and the logic here is that, remember talking about running a nefarious router and doing nefarious like overselling or turning the router off and these kind of things. If you can just turn the router off, then we need to trust you, and there's no way to prevent somebody from selling bandwidth and then turning the router off. It's just an intractable problem. And once we understand that that's an intractable problem, we don't need to go out of our way to make the token system more secure than the ability to even use those tokens. So making it so that every router just creates its own micro blockchain and then sells tokens on that blockchain, and it's just signing every block itself. It's just with its key. That's a working solution where you just relax the security requirements a little bit, and that makes it so that instead of having these $2, $5, whatever Ethereum transaction fees, we are able to have transaction fees of nothing. It's like it's free as in email is free.
Okay. And is there some sort of a cap, a market, a Coinbase amount, a total amount, or how does that work?
So when we're talking about
you said it was
packet,
6 billion, right? 6 billion, right?
And then, but that's the packet blockchain.
Oh, that's the packet blockchain.
You can issue any token you want for any purpose. Yeah. You can set the cap anywhere that you want, and that's all up to you.
Well, who would
buy it? Well, that's the interesting thing, because you buy that token so that you can then turn around and say, here, I have the token. Please allow me to configure your router, because I have a token worth 10% of your bandwidth for the next month.
Oh, I see. And this is also time locked, so it after a while it just extinguishes itself.
Exactly. This is how futures typically work. They have a limited amount of time, a limited quantity. How would you be able to sell? I mean, you can't sell 50 years into the future of a token.
Sure.
Enron did that, but that's not good practice.
Okay, I see. Oh, I see. How long has this project been going? You've been cracking at this for a while now, haven't you?
Well, I mean, I've been thinking about it since at least 15 years. But I mean, CJDNS started 10 years ago. The Lightning Network wasn't there until about 3 years ago. And then Lightning just started to become stable. And I was doing research for a company called XWiki. I was a research manager, and I built a project called Cryptpad, where you can it's just like a document editor where you can collaboratively edit documents with people, and the server doesn't know what you're typing. And that's because we encrypt everything browser to browser. So, real-time collaborative editing without the server's knowledge, that was what I was working on at that time. That project's still ongoing and doing well. And then, about 2018, Lightning Network started to warm up and things started to be happening. SegWit landed in Bitcoin. And so that, then Lightning Network started to become a thing. And that was when it was time for me to wake the project back up. So back 2018, the conversations were being had about, okay, it's time to get something together and start building something. And then, so 2019 in August 20th, I believe, that was block one. Actually, August 15th was block one, and August 20th was real block one, because there was a bug first iteration. So yeah, August 20th of 2019 was block one, and we've, and then we went just headlong into coronavirus season, and everything got shut down immediately. But we've made a real comeback in late 2020, early 2021, and things are now. It's like things are really beginning to look positive for the project.
And is this mainly in the sense that you're getting a lot of project applications to the Stewart?
Oh, no, I mean, it's in the sense that the community's growing. There's 3 major mining pools. There's a lot of activity, a lot of people doing things. So yeah, I mean, the network steward, that's a difficult thing, because there aren't so many people who know how to do research. So my background is research. I applied for projects with the European Union, the French government. I've managed projects, went to the project reviews. So I have a lot of, I have 3-4 years of experience just being in charge of research projects. So I know what to look for. And unfortunately, a lot of people, it's rare to have people who really are able to foster a project. Just computing the number of person months, how much time is it going to take, and then computing the price. A lot of people just, they put in random numbers, and then the reviewers look at that and it's not going to work. So that's been a challenge on that side. And I've been reaching out to funding bodies who can break down funding into smaller pieces. And remember, network stewards all volunteer. We can't fund the network steward directly. We can't pay these guys to evaluate projects, because the way we'd have to do it would have to be through a not-for-profit organization, and it's just too complicated to do it and be sure that we're not just basically putting the money in our pocket. You can go to the Network Steward's GitHub. It's a big mess, but you can go there and you can validate, and you can go on the Block Explorer and you can cross-check every single transaction the Network Steward's ever made, and you can see which project that transaction was funding, and then you can trace that project back to the call when that project was accepted and the other projects that were proposed and why that one was accepted and the other ones were rejected. So everything is there and it's all transparent. You can audit the thing till you're blue in the face, and that's how we want it to be. But that makes things very slow and difficult for the network steward. So I personally, as a community member, am talking to different funding bodies that are in the business of funding research, because they can take a big network steward, they can do a network steward project, and then they can turn that around and they can break it out into 5K, 10K for different developers, 50K, whatever. And then they can manage a whole bunch of projects, and they have the administrators, and they have all the things that are necessary. So as a community member, I'm thinking about putting in a project to the network steward, which I would then recuse myself as a voting member, and that project would bring in one of these funding bodies so that we could have a little bit more professionalism. We have the transparency under control, but we just don't scale. 5 volunteers doesn't scale.
Yeah. As soon as that starts getting more hairy, I can imagine you guys would just be like, "Oh, fuck this."
Yeah, exactly.
You're not doing fun stuff anymore at that point.
Exactly. So we're trying to keep the number of projects reasonably small. We just can't manage 30 or 50 or 100 projects. And if we tried to, then there would be money going out the side door, and we wouldn't be able to keep track of it. So having real administrators working on this is something that is very much on my mind right now.
Let's go back to the networking stuff now. You're familiar with the narrow waist of the networking protocol, right?
The narrow waist?
Oh, okay. Well, yeah. The narrow waist, which, for example, if you were to look at the networking, this is not a very good example, but if you were to look at the networking protocol as an hourglass infrastructure, imagine an hourglass, right? And then on the top side of the hourglass, at the very top, you've got your applications. Then you've got your different protocols and whatnot, and then right in the middle, you've got IP.
Okay.
And then underneath IP, you would have your different, the different transports. And then you'd have, like, at the very bottom, you'd have like Sonnet, and then at the very bottom, you'd have, like, the wire or radio frequency, et cetera, et cetera, et cetera. So you can see that, like, the top portion of the hourglass would be what, and the bottom would be how the data moves. Essentially. So both sides of the hourglass see IP. Yeah. They need to see IP in order for this thing to work. And this is why the narrow waist of this, it really needs to be simple. It needs to be simple, because as soon as you add complexity into the narrow waist, everywhere in the network that sees IP needs to support every single goddamn feature. So this is why, to me, when I see, like, IPv4, IPv6, to me it's a train smash, because it's like everybody needs to support all these different features. So Now, you mentioned that in your networking protocol, I imagine it's a request response kind of thing. So I request for a name, and then what happens is I can either get an IP address or I get directions to the data.
Right.
So there's an indirection, right?
Yeah. So yeah, the IP is like the lingua franca of networking, because everybody on the top, you have this diverse set of applications and they all speak to IP, and then you have this diverse set of transports and they all speak to IP. So if I'm understanding you properly, it's really the lingua franca of the IP of the networking world.
Correct.
So CJDNS doesn't try to replace IP as lingua franca. The applications are going to speak IP. They're going to speak IP4. There's applications that are never going to adopt IP6. I mean, they should, but they probably won't. CJDNS is going to be, it needs to run on the endpoint, but it's going to be able to offer an IP-like experience for existing applications, because it just needs to emulate. It runs under IP, and it uses IP6. As you probably know, CJDNS uses the IP6, where the IP is the hash of your key, so that you can just allocate. Anybody can just have an IP address. Just snap your fingers, you make a key, you make an IP. But when you're getting into the VPN space, and if you want to talk to the regular internet, then you need to be going through a VPN, which the cloud ISP, we're talking about running VPNs. And those are going to be issuing you an IP4 address, an IP6 address, whatever addresses, so that you're able to communicate with like Facebook until they decide to upgrade to using CJDNS natively, which they probably will. I mean, they've got a Tor exit, so it shouldn't take them that long. But I mean, not that Facebook is the greatest thing to connect to when you get to the internet, but this is what we're dealing with, and you got to get people where they want to go.
Okay. All right. Okay. So you're doing nothing major along the lines of shifting the narrow waist at all. Is that right?
No,
Okay.
and that was an early learning
Design
of CJDNS. We looked at other projects. There was I2P and Tor. Tor is pretty good because it's just a proxy, and lots of things talk proxy, SOX5 proxy. I2P, not so easy. You really need to kind of integrate that software. Freenet's a great. It was a great theory. It was also a great exploration into how. Yeah. But it was a good exploration into what happens when you give people too much anonymity, because Freenet just got attacked and it got wiped out by, terrible stuff. People putting bad stuff onto the network, and it just caused this like decay and all of the developers, they all just basically stopped working on it because they didn't want to work for that, and it was really unfortunate because. Brilliant protocol and a great idea. The white paper, the PhD thesis on it was just a brilliant piece of work, and it still is. But that's just what happens to you when you don't build in social controls on certain types of activity.
Yeah.
But also, what I was getting at was that Freenet required you to kind of adapt your application, and so it wasn't just IP, and that was one of the things that was significant in CJDNS. Is anything that spoke IP6 spoke CJDNS, so it was very quick to adopt. And we want to keep that up.
Yeah. I'm also in the process of writing a networking protocol, but I'm actually shifting the narrow waist. I'm shifting it to the point of a Bloom filter, basically. So I convert a name to a Bloom filter index, and then you've got a network that all see and understand these Bloom filter indices, and then they would have an own sort of like each interface would have a the Bloom filter basically, and then you would say, oh, have I seen this data before on this interface? No. Okay, let me flood it. And then every node would say, "Ah, yeah, okay, yeah, I've seen this one before. I know where to route it. I know which interface should have that." And then it just gets shot on down eventually. And eventually, a node in the network might have the data, and then it just returns along the path that the request left a breadcrumb trail, basically.
Yeah.
So along these lines. So it's still so new and well, I mean it hasn't even been deployed yet, but I'm kind of curious about to see how things are going. So having your experience and your knowledge, like sharing it is quite valuable to me. Understanding these pain points, and it seems like the main pain points are just human related, really.
That's a big part of it. And so if I understand you properly, your protocol, what's it called? Did you give it a name?
Yeah, I'm calling it Copernica.
Copernica.
Because I'm shifting away from host-centric networking to data-centric networking, or information-centric networking. Yeah, right. Maybe you know about information-centric networking.
Content networking is a very old. There's a lot of research on it. It's been tried many times. I mean, IPFS is the newest one. Obviously, Freenet was an effort at content networking.
Content-centric networking. Yeah. And what's your opinion? And you tear it apart.
I'd love it. I'd love it to work because it's really what we should do. I mean, I'm being, let's say, cowardly here because I'm just saying, well, let's just stick to sending packets between computers and that's it. That's the content-centric stuff is really where we'd love to be. The problem is that there's a lot of problems that need to be solved. Like, who's paying to host that content? That's kind of thing. I mean, Filecoin is attempting to answer that, where you would pay to put the content up. What about who do you call if that content doesn't get to you fast enough? You need that who do you call issue. Whereas, if you go to like Facebook or something, keep using the example, but if you go there and it doesn't load fast enough, well, that's Mark Zuckerberg's problem, and that means that it's somebody else's. That problem goes down the line, or it's your problem if it's your ISP. But there is this who do you call answer here, and with content centric, you risk to end up in the same situation as the DHT routing, where you don't have that who do you call. If you can answer that problem, then I mean, we're all going to be using your protocol in 20 years anyway, because it is fundamentally superior. It's just that the limitations of it, and I mean, I highly recommend reading about some of the next generation internet research that's been done in Europe, as well as obviously the experience of Freenet, the experience of IPFS, and BitTorrent. BitTorrent's another example of content networking, and they work really well in their contexts, but they've also had limitations which made it very hard to work. Now, I think that there's an opportunity for these things to work together. And I mean, people also talk about, people have asked me, why did you not make CJDNS anonymous like Tor? And I mean, the answer is because Tor can run on top of CJDNS. All I care about is getting people unfiltered, quality access to an encrypted network where they can communicate with other people. And let's just get that. And then we can run applications. We can run all different kinds of solutions on top of that. So, I mean, I think that the content-centric stuff it's definitely a big deal, and it's going to become a bigger deal once we're able to identify the cost of getting data from point A to point B. Because right now it's very nebulous. We've got CDNs, but we have CDNs because at the backhaul level, we know what it costs to get data from point A to point B. But we're connecting to, I mean, you have an ISP, I have an ISP, and I have a 100 megabit connection, and the ISP is basically telling me, you can use whatever. we're not worried about what you use or where you send it. And so that for them, they're telling me that it's the same cost to get data to Hong Kong as it is to get data to Paris. I'm just outside of Paris. And that's not true. That's not the reality. And once once packet network becomes a thing, we're going to know exactly the cost to get data from any given point A to point B. So the ability to do local hosting of data, in your local neighborhood, that type of stuff, that's going to start to be actually economical. Whereas it wasn't in the past. It's just like we've all got these ISPs and they're all telling us that data to Hong Kong costs the same as data to Paris, and it's not true. And they're telling us that, so we don't really have a way to price CDN.
Yeah. Yeah, you're right. I find the most difficult thing of this thing is the economics. It is fucking hard to think about. So I've just sort of resorted to sort of like, would it even be a cowardly solution? But my thoughts are, well, initially, why not just let people peer with each other? You would provide either a MAC address, or if you're on the LAN, or an IP address. Or even it could just be like lasers firing at each other, or radio frequency, and then let it be that way. But every single node is running a lightning node. So in that way, one is incentivized to keep your node up and running because it's paying you Bitcoin, right? So.
Right.
And then maybe I'm shirking it, but like at that point, it's like, let a solution evolve. If you've got the basic economics in place and you've got the ability to route payments using this maybe RGB, I still have to do research in RGB. You should probably check it out. And
it's in our white paper. I mean, we mentioned that it can be a solution. I mean, we're looking in the direction of token strike, but so that's our own, make your own blockchain, build your own blockchain, bring your own blockchain solution. But RGB is an alternative to that, obviously, because you can just create those tokens.
I was just introduced to it last night by Max Hillebrand, and I was okay. This sounds very interesting. I'll do some further research into it, but. Yeah, my point is that just offer that ability for people to sort of like make payments or route payments, and then they can charge a little fee for routing the payments, and that layer still occupies the same layer as the data layer because it's all content really at that point. It's all just data, and then eventually maybe nodes would say, okay, you can peer with me, but you need to pay me a certain amount of the equivalent of an ISP. So instead of like in my network, I don't want to have a global view of the network. I don't want to have that. I see it. It should be like my little node should be operating under my rules. I want to be able to shrink an ISP down to a single node, my node, and it has an immune system, and I can control the immune system, and I can say, okay, you can peer with. I can peer with you, and you. And if any of you guys start messing around, I'm just going to, disconnect from you or shut you down or slow you down or something like that. So, I tell you, this is a really difficult domain, but it keeps you out of mischief, it keeps you mulling about these things. And
I mean, if there's one piece of advice that I would
love
give
to hear it.
is when you have a difficult economic problem, the one thing that you might want, there's one tool that you may wish to use is a financial market. And you just make this the problem of traders to trade that asset. So you might say, I don't know what a gigabit of data or gigabyte of data on Caleb's computer is worth, in Paris, near all these networks in Europe, but not near Hong Kong, and I don't know what this was worth. So I'm just going to allow that to be tokenized, and then put that token out there, token strike, RGB, whatever, and then let people trade that token and then redeem that token for that data. And if somebody loses the data, well, that's where the reputation comes in. The Filecoin people have done a lot of effort to, what I would say is kind of square the circle and solve this algorithmically. And if they can, that's great. But it's easier to kind of just throw a financial market at it. And if you do that, it's like that market will function because we know how they work.
I firmly agree with you, and I'm a strong believer in markets. They're absolutely wonderful things. We would not have the society without them. So like I was thinking along the lines, eventually people could just list up their peering connection thing. It's like, okay, I still have capacity now, and then you just stick it on some sort of a market, and then see what people will pay for it. And in that way, your network is always evolving. It's always changing. It's adapting. So it's like the topology of the network adapts to the markets. Do you see what I mean?
Yeah.
That in itself can be quite beautiful, I think.
Yeah, I just did want to comment about the market because they do go wrong, and they're not a solution to everything. So it's a tool that you need to use carefully, knowing what it can do and what it can't do, and where it will kind of blow up. Because for example, a lot of it's in the U.S. It's very popular for people to just say, "I'll let the market handle it." And if the market is designed, is able to do that, if it's organized in such a way that the market does lean toward handling it, it'll handle it. It'll be great. But if it's not, if you don't use that tool properly, it's a powerful but dangerous tool. And if you don't use it properly, then you can end up in a situation where people are ranting that free markets were a mistake and we should go back to communism or something like that. But it's just, as long as you have an understanding of what the costs and benefits and how to use that thing safely, I think that's more the thing.
Yeah. Well, I think I might just sort of just kick that bucket down the road a little bit and just just get Lightning up there and then good enough. Thank you very much. Let's see what happens from there. A lot can be done just with a hash time lock contract or maybe even RGB. I still need to go into this. I'm thinking of interviewing the author of RGB just to get an understanding of what's going on there.
That would be fantastic, because my understanding is still cursory about it. What I understand from it is that you're able to create Lightning contracts where if you're tracing a Satoshi through the network, as per the colored coin model, you're able to create these Lightning contracts where at any point, if that contract executes or blows up or whatever, that particular Satoshi, in accordance with your tracing process, will end up in the hands of the right person. So that's super powerful if you can do it. The only thing I would say is a limitation there is that you need to create that Satoshi to begin with, and so when you create it, and also when you set up these agreements, you're paying some transaction fees there, but that's very small in comparison to the ability to transact. I think that at the end of the day, Token Strike will outscale it, just because you bring your own blockchain. There's nothing that scales more than a completely isolated blockchain. But I think that RGB is still a serious contender for the future of tokenizing assets.
Okay. Right. Token Strike. And you got a paper up there, right? I can read it, or is it subsection of a paper or something? Or is it just in your head?
No. It is. There's a couple places you can look. You can look at the white paper of Packet. So you go to pkt.cash and you click up in the upper right white paper, and then there is a paragraph that just says what roughly Token Strike would do. Yeah. And then if you want to read the spec of it, the requirements, then you can go to the PKT-cache GitHub group, and then inside of that GitHub group, there's a repository called NS-projects, and this is the network steward repository where all the records are kept. So that's the place to audit. And inside of there's a group called a file called tokenstrike.md in the project list, and it's an accepted project. It hasn't received any funding yet because it didn't ask for any prepayment, and it hasn't achieved any results yet. But if you go there and you read that document, then you can read down from the top and see, what are the objectives of that project, how it's basically going to work.
Okay. All right. So what brought you from the US to France?
In 2013, basically
it was a woman, wasn't it?
No, actually, it was an opportunity because I could have gone to to California and been a junior developer in California. Where I came from was rural. There's no money, no jobs. Unfortunately, it is what it is. Rural areas just don't have the money. And that's now changing because everything's remote. So now rural actually makes a lot of sense. But at the time, if you want to make money, go to the city. And the cities that were the options was basically, Silicon Valley or New York or these kinds of places. And the cost of living in those cities is extraordinary. Whereas going to Paris, it was a lifestyle that I more enjoyed. I appreciate the European lifestyle. And the cost of living versus the salary was just a better deal. I never had the experience of being broke when I lived here. And I started as a junior developer. I didn't start out as the research manager. I was just developing software. And and I've talked to other people about this. And you can be a pretty high level person in your job, and you live in LA or wherever, and you're going to have that experience of just being broke. You've got the car, you've got the house, you've got all these expenses and all this money that you're expected to pay. It's expected. You must blend in with the society and be a baller and have lots of money. Whereas in the European lifestyle, Parisian lifestyle, having lots of money is not such an important thing. They actually don't like you if you have money. So it made for a much easier lifestyle. And I also say that I have disagreements about the way that the U.S. operates, and especially at the time under George W. Bush, and that was impactful on me as a teenager growing up, and getting to move to Europe. Oh, also 2008. It was like the apocalypse in 2008, economic apocalypse, and
oh yes,
yeah. At that time, it just felt like Europe was a more positive place to be, and the economics worked out, and it was a new experience. So I moved out of my dad's house and moved to Paris. That was my moving out experience.
Wow, yeah, and now you're having croissants on the cafes on the sidewalk. Is that right?
Yeah, I've had my share of all that fun stuff.
A good percentage of my good friends are French. And as soon as I said I'm going to have an Indaba with you, they looked at you and they're like, oh, you better be careful. He's French. No, this is just French. French are very disparaging of other French people. I'm sure you know that.
Okay, yeah. So
it's nothing personal about you.
No, I just find it interesting.
Yeah.
What I've heard of is two French people meet on the street in France, and they're naturally enemies. But French people meet on the street in America, and they're naturally friends because they have something in common.
Oh, that's interesting. Oh, okay. That's a bit different in Hong Kong, because I think there's such a large amount of French people out here. They've brought France to Hong Kong now.
Okay.
If a French person meets another French person on the streets, they're like, circle each other like, cats, like.
Oh, that's
quite
interesting.
It's quite amusing. You just go to Sheung Wan, and there's a whole cordoned off area which is all like French speaking. It's not that bad, but along these lines. And I suppose it's also good for you being in Europe, because there's a lot of like a cypherpunk activity. You got the CCC going on there, or do you avoid all of that stuff, or do you go and check it out, or what's going on?
Yes and no. I mean, sometimes I've been to the CCC a number of times. I'm not a member per se. I'm not sure if they would have me as a member. I like the way they do things more than the way the American hacker community. The American hacker community is just so focused on breaking things, and that's not sustainable. And also, it's very spooky. There's just like, the joke is the DEF CON is the biggest NSA recruiting event. It's like everybody. It's very macho and very like I can hack your computer kind of thing. And so in that context, I very much appreciate the CCC as being an art focused and more my speed of things.
But also in Germany, they've got there's entire networks. There's entire groups of people who are very supportive of creating these separate internets, different Wi-Fi communication pathways. They're more than willing to pull fiber through the drainage if they need to or have to. It's quite a nice little culture, and there's a more respected, privacy is more respected out there. I think this is a lot more along your lines of thinking too. But doesn't that make you a bit complacent?
Well, I want to dig into that complacent a little bit more, but I was just going to make a comment that Germans. Okay. I mean, I could never really live in that culture because I can't stand the level of rules of
I know
restrictions that are accepted in that culture. Yeah. I get along with the French because the French are just anarchists by nature.
Viva la France, Revolution.
Yeah, exactly.
Me
exactly.
too. I love that too.
Whereas, Germans and Swiss, I just have to understand that as much as I appreciate what they're able to do together. I've heard a story. I spoke with a friend. He lives in a house where everybody puts their entire salary into a pot that funds this whole community house, and exactly. That's the level of coordination that these people are able to achieve, and I'm just like in awe because it's not something that I would ever be able to do myself. For me, I have too much the American. I need to what's mine is mine, and so on and so forth. But with that level of coordination between people, they're able to achieve really, really incredible things.
Yeah.
So I just have to look on from the side and say, "Wow, that's amazing."
Give them applause from the sidelines, right? Like exactly. I could never run your marathon.
Exactly.
Dig into the complacent comment.
So I want to understand, what do you mean?
What I mean by that is, growing up in South Africa, we also had shit internet, and I've always been thinking about how to make, sort of rogue, sort of guerrilla internets and along these lines. And, coming to Hong Kong, all of that sort of fell away because the internet infrastructure is so damn good out here. And then I think it sort of like fired up, what with all the protests and the Chinese government taking over and all that sort of stuff. And You know, one of the main reasons I came out to Hong Kong because the internet is so good. And having the internet taken away from me, I'm going to pull out my knives. I'm going to fight for it, you see. So I've no longer complacent. I'm actually going out and creating stuff to ensure that no damn government or monopoly or Google or any of these fuckwit companies and state actors can do this.
Yeah. So I mean, I think that we're in brothers in arms on this matter because I mean, you know, Packet is fundamentally about making an encrypted network that covers the whole internet, the whole world. And if anybody wants to block that, then it's basically just the black market economy of getting around that block. You know, the Chinese government couldn't block Bitcoin mining in China. They did what they could, but crypto is still a huge thing. And so connecting crypto to freedom of speech and freedom of communication is a way that we can make that something that's actually unstoppable. So, I mean, on complacency, yeah, you're right. I have 100 megabit internet at the house. I'm considering buying another internet for my business so that I have dual connections into the house. And I'm paying $50 a month for 100. And I could just pay a little more and get a gigabit, or they even have 10 gigabit here that you can get from this provider. Although I think if I got 10 gigabit, I'd use it. And if I used it, I'd probably get a call and be like, "What are you doing?" But anyway, yeah, I mean, we have a really wonderful internet situation here in France, and a lot of that, I mean, partially it's because people are serious about public and private. They use public money to roll out a lot of fiber. Now, this is not the situation in all of France. This is the situation in the Paris area.
Right.
Paris takes care of Paris. Paris is not France. That's something like that's understand about France. Like Paris and France are actually at war with each other, and they have been for like the past 2,000 years. But you know, I guess I live in Paris. But for the most part, I mean, I'm an hour outside the city, but technically, this is, or in practice, this is Paris. But anyway, the reason why we have such wonderful internet here is because of a company called Free. And that company, it was founded by a guy named Xavier Noel. And he basically, I mean, he did what Cogent did to the backhaul companies. He just said, I'm going to make the internet, I'm going to cut the price. I'm going to do 1/10 the price of what all the other companies are doing. And he went in there with 1/10 the price, and they all had to match him, obviously. And he really put a massive amount of pressure on France Telecom, which is Orange, and the Bouygues and the other incumbents, Numericable, and you know, he pushed the price individually, like alone. That company pushed the price of internet down in the entire Paris area, and I mean around all France, just by entering that market and insisting to continue to innovate and continue to make things faster. And like the lesson to learn is that new entrants are what make a market. That's what makes a market dynamic. You know, if you can have 10 participants in a market, but if it's the same 10 that have been there 100 years ago, they're all going to have some kind of agreements with each other about not competing too much. Yeah. So it all tends back to monopoly. But yeah, I mean, am I complacent? Well, I like my internet. I like my coffee, and I like my French lifestyle. And I live down the road from a butcher shop and a pizza place. I live across the road from a bakery and a convenience store. You know, it's hard to beat.
Yeah, I know. I can immediately visualize what's going on. But I suppose you also do a lot of travel in Europe. Well, I mean, prior to COVID.
Yeah. Well, I mean, anytime I had the opportunity to meet somebody or go to a conference, that was my, if that existed, then yeah, absolutely. And
where was your favorite place in Europe?
Well, that's a great question. Paris, of course, because I'm here.
Are you just currying favor with the Parisians?
Yeah, I mean, all the different cities are interesting in their own way. I mean, Berlin has this very dynamic culture, and I mean, Amsterdam. I don't think I'd want to live in Berlin, or I wouldn't want to live in Amsterdam. Great places to visit. You know, and nice people that I know that live there. And then, you know, going to the east, there's my wife is from Iași, Romania, and you know, that's also a beautiful place. And they also have really fast internet in Romania. That was something they prioritized. And, you know, been to Prague, been to Italy. Being a research manager, I actually saw a lot of places because we would travel to visit the different cities of the to do meetings with our collaborative organizations and institutions for the project. You know, so Italy, it's beautiful down there. Again, you know, where do I want to live? I want to live in Paris. That's the place I want to live.
Was this the Horizon 2020 European thing that you were working for?
Yeah, we did H2020 projects. I closed up a couple of FP6, FP7 projects back when that was a thing. I did some. I forgot.
What is FP6? What is FP7? What is that?
Framework Program 6, Framework Program 7. These were the predecessors to H2020. And then. Okay. There was also French funding bodies. I don't remember the name, but there were a number of French. BPI was French. French really know how to do research projects. They founded a bank just to fund research projects. Like they founded a Bank of Public Investments. So you know, when you did a research project with the French, they definitely knew how to do the paperwork aspect of it.
Yeah, so the Horizon 2020, I mean, that seemed to be like the one that channeled like, billions of euros. And then there were a number of subsidiaries, organizations, which was associated with them. And it would be their responsibility to go through the applications and then give, and your responsibility would to find these subsidiaries. Is that correct?
At the time that I was involved, that the subsidiaries was not such a big thing. So we were going directly to the European Union as a group. We would be a group of 6 to 10 or 6 to 12 institutions, universities, companies, small businesses, and we would go into this, and we would actually have to go to Brussels and explain ourselves, to explain how we did the project and show what the results were. Now, the subsidiaries is a brilliant move, and like that has improved the quality of research. I mean, my opinion is tenfold to have these entities who, again, they bring the administration aspect and they can break it out into 20K, 50K, even 10K, 5K projects, and then they can allocate that money to these individual open source developers who are in the trenches typing code and that don't really know how to write an 80-page proposal, and get together with 10 other organizations and then go to Brussels and explain. And so having like these organizations has really been positive. Now these are the organizations who I'm trying to convince to work with us on the Packet project so that they can actually manage network steward projects, because I've seen what they've been able to do, and it is very, it's fantastic.
Yeah, on the receiving end of because I also made an application to NLNet for this project, which I did, and I always shut down. I think I got past the first stage, and then afterwards I was shut down. I think, was it Michael? Michael told me to, he said like, no. Just no. Thank you very much, but no. So I was like, I think that was the last time I just sort of like, because NLNet is like, one of the old guard of the old school internet, and being sort of turned down. I mean, it's not bitter grapes, it's not sour grapes or anything. I mean, everybody's got, it's difficult enough to do this sort of stuff. But when NLNet turned me down, that was a bit of a wake-up moment for me, because I was like, this is one of the bastions of the free internet, and this potential future internet candidate got shut down. So I was like, okay, I'm not going to ever rely on funding from any organization ever again. I'm never going to do this thing. It's just like, okay, that's it. This is all done by myself. Because
I think
it was the straw that broke my back.
Yeah, I mean, I think that's not the right attitude, because
Do you know how much time you waste? I could be writing code. Yeah. Oh
Yeah,
no, just going from different funding organizations to just fuck it. I could just do it myself, and
whichever way works out in the end. But I mean, I did a lot of typing. I typed a lot of projects. I got rejected. I got a lot of rejection letters. And the people who, like, take for example one of these big companies, a Nokia or something. They've just got people sitting there typing all day, and they just applying to projects, apply, because they're just figuring eventually they're gonna get one. And so that's kind of the attitude you have to take in order to start winning projects. And also, I mean, that's related to this situation, is that I mean, I've got a project I just put in a project for related to Packet, just see if I could get some funding for doing a bit of research with some research partners. It's not that we don't have money in Packet, it's that the people who are in the research space it's easier for them to understand money when it's coming from a funding body. So, we work together to put this project in. And if I had said, I want to hire you to do a research project in this context, they would have said, what's that? What is this? But saying, hey, let's work together and make a project, and we're going to apply to NLNet. Actually, we applied to Funding Box. Then it made a lot more sense, because this is something these people have experience with, and it gives us this outside validation that this is a valid project, this is a good use of funds. So I put that in. I'm waiting. I mean, if we get accepted or rejected, it is what it is, and maybe I'll reuse that proposal, some of that text, to put it in another project at some point. Although I feel like I'm probably going to be in conflict of interest, so I should probably not propose any projects to these people, because I'm calling them and I want them to actually be below me as the issuers of the project. So I should get projects from them.
So okay, given that's a pretty interesting subject to talk about. Like I think maybe a number of people that are looking at this sort of problem might benefit from this knowledge. How would you, given your experience and knowledge of working with Horizon 2020 and doing all the funding and whatnot, how are you going to structure this Packet funding thing? Because I think a lot of programmers and even Bitcoiners might not appreciate that the amount of shit crawling that goes into getting projects funded, and like they can disparage a supposed shitcoin. They can disparage it, like, if it's not solving a problem, Right. But yeah, go into it. How will you structure it?
So we already have. We have a structure for funding. We've funded about 10 projects so far, and the funding structure is. You need to fill out basically a markdown file, which is your application. And the key things we're looking for is success criteria. So, going back to H2020, there's a way there's good ways and bad ways to win a project. And the bad ways are that you just get the right people in the project. If you've got the big companies, I'm not going to name any names, but you've got the right companies that have the lobbyists, and then you're going to get the project. But the good way to win a project, and you use a combination of different ways, but the good way, the positive thing to do, is to write solid success criteria. You're basically saying, if I don't deliver this and this and this by the first milestone, then you can shut me down. And when you say that, then the funding body is able to say, okay, we know what we're getting for our money, or we're not, but they didn't just say, give me some money and I'm going to maybe do something or not. They're saying, give me money and this is what I'm going to do. And these are the hours I'm going to work on it. And then these are the KPIs. So you really need to focus on success criteria. So success criteria is, this is the definition of success. And if this thing is not achieved, then we didn't succeed. And the KPI obviously is, you can measure our results by this metric. This is the thing this is the number we're going to make go up, basically.
Okay. All right. Okay. And that's the sort of thing that you're just going to tell to everyone who's going to apply for these things. But then how are you going to scale that out? I imagine that you'd want to go to,
Michael, Michael, that's how we scale, is that we get, we get people to operate.
Michael from NLNet, right?
Yeah, of course. That's the idea, is that we need to get people in and, to be able to do the administration aspect. We have our process, and they can adapt the process, to what makes sense based on their organization. But we need administrators.
But there's a further problem that you have is that there's not much price discovery in this packet token. You see what I mean? How do you
price it out? Well, there is a Telegram trading chat, and there are people discussing, and trading the coin for, and pricing it out in dollars. So there is some price discovery. You're right. There isn't as much as there would be if it was on exchange, and it's a community coin. So I feel like getting to an exchange has been a longer road for us than it would be on, one of these centralized tokens where somebody, just printed 30% of them into their own pocket, and then they kind of give them with all their friends, and they give them to the exchange to get them on the exchange. So, for us being a community coin, we needed to go around to our community, and there are some initiatives going on to try to get a packet onto an exchange where there'll be more price discovery. But right now, the price, people have traded at, if I said 3 cents, that would be a little bit high, but I think 2 cents is a very stable price at this point. When we started, we kind of just said, okay, it's going to be 1/10 of a cent. That's our imagined number. And then, over time, it went from 1/10 to 2/10 to 3/10, and it was actually 3/10 of a cent, only a couple months ago. And then, how crypto projects work is, everybody kind of piled in the chat, and all of a sudden, it's gone up to, 1/2 cent, and then 8/10 of a cent, and then a cent, and then now 2 cents is happening. But the point is that it's been a very organic and slow process to get there. So I feel comfortable about those numbers, as opposed to it's like somebody just said this is the price, and people kind of for some reason believe them.
Okay, all right. And somebody like Michael of NLNet, I wonder how he would take that. Has he already heard what's going on here?
Well, yeah, we did talk. I'm leaking information here, but
then don't.
It's nothing secret. It's just I did talk with him because I want to make this happen. And the idea is that NLNet's not prepared to really take on a cryptocurrency, so we would have a financier that would come in, and they might be, but we don't want to ask them to, it just slows things down too much to ask them to take that on their books as an asset. So it's easier to just bring in a community member who's looking to load up on Packet at a fixed price, and then that community member would be the supporter for that initiative. And there are some people who would be interested in doing that.
Okay. Yeah. So yeah. Oh, there's a lot. It's quite challenging. So challenging in so many different ways.
It's fun. I have fun every day.
It is fun. It is fun, but it's still bloody challenging. Yeah, I mean, so okay. Then the rewrite of the C. Don't you think you should rename it? Don't call it CJDNS. Are you gonna... I can see that ego. Because I mean, it doesn't do DNS anymore.
Well,
You can still keep the CJD.
Yeah, but I mean, it never did DNS, but it will. I mean, in the future it will, because the name lookup is integrated into the route lookup. So these are related. So in the end, CJDNS will actually resolve DNS.
Full circle.
Yeah, exactly.
All right, stick with it then. Yeah. Well,
we
anyway,
we try not to change things if they don't need to be changed. You know, the whole sticky protocols and measurements and such things.
It's true. Like the name CJDNS is now out there. Everybody knows it. Everybody knows it. Yeah. You're a bit of a rock star in this domain.
I suppose so. I mean, the reason why CJDNS stuck, I mean, originally it was going to be a DNS router, a DNS server, but I started working on the code, and it actually came from an IRC channel called DNS P2P, and that was created by Broke P, aka Peter Sunday of the Pirate Bay fame, and he started that channel in 2010, I believe, late 2010. He started that IRC channel and said, "We need a solution to DNS," and that was where a lot of people started getting together and talking, and in those conversations, a few different proposals for DNS actually, emerged. One of them was Namecoin. That's where Namecoin came from. It was in that channel where the person who initially created Namecoin, they did it in that channel. And I remember that's where I got exposed to Bitcoin. Bitcoin. Everybody was talking about it. But that was where CJDNS got its start, and we were talking at that time about doing a DNS server. But the reality is DNS is a very difficult problem. It's a political problem. Who owns a domain is a political question. And if you can just grab a domain that really is somebody else's their name, and you're just taking that and then disparaging them, or you're running malware or that kind of stuff, like these are the problems that have been plaguing fully decentralized DNS. And because it's such a political problem, it was something that once I understood it, I said, okay, we're going to solve routing instead.
How are you going to solve it now? Now that you know, I mean, okay, so the main issue is, like, I have a name, say cup, and or microphone, and now I own this name, right?
So we're gonna punt this problem, and we're gonna punt it to the cloud ISPs. So you'll just resolve DNS with them. They'll probably resolve it with ICANN. I'd love it if they'd also do .bit domains, because then that would loop Namecoin back into the mix. Because Namecoin is a great project, and I know Jeremy, and they're actually funded with the Helnet now. Again, example, like these crypto projects, that when you don't have an explicit method to fund the development of the project, then the developers have their hat in their hands. Yeah. No, the way I approached this particular problem was like, fuck it, I'm just going to put your public key, prepend it to everything, and this gives the uniqueness, and of course the data is signed. So in this way, like, you can have your public key microphone, and I have my public key microphone, and the two will never conflict. And of course, the data will never route anything that doesn't check the sign. Doesn't pass a signature check. That's an easy solution. That gives you links that will always work. So that's incredibly good. For some reason, people don't like that. People like links. I know. But this, the way to reason with that would be like, okay, and maybe on a software level, you can have the equivalent of an address book. So I would just type in CJD microphone. Right.
And then there would be a lookup, but it would be a local lookup, and the only lookup would be to convert CJD to your public key, and then that goes out onto the network.
You know, we did a lot of research on that topic is GNU-net. They had this pet name system where you could define the name of something yourself, and then there was this delegated pet names. I don't know how well it worked. I mean, it didn't work as well as ICANN. I think the problem with ICANN is that so the problem with Namecoin is that if you're going to pay for a name, you might as well pay for a name on ICANN where everybody can just resolve it instantly. And I mean, that was just the death of Namecoin. And then, the pet name system and GNU-net, I think GNU-net is really, really interesting, a lot of interesting research going on there. It should get more press than it does. They attempted to solve this. I think maybe it doesn't get as much press or it doesn't get as much attention as it ought to for the quality of research, because they try to solve every problem from layer 1 all the way to layer 7. And, it's like you must use the GNU blah, blah, blah for everything in the GNU-net world. I'm just kind of riffing here. But
you're not really. Because there is that element of like a strong ideological sort of drive in that field, in that area, which is, it's done a lot of benefit to the world, but too strong an ideology for everything can have negative sides too, I think.
Yeah, but I mean, it's positive from a research perspective, because all the things that are learned there can be reapplied in a more what's the word, more reasonable, realistic context where it can be industrialized.
That's interesting you see it that way. Yeah, that's very forgiving of you.
I'm a fan
and
of
practical.
research.
Eh?
Yeah, practical. That's the word I'm looking for. But I'm a fan of research. I'm a fan of the idea that you do fundamental research, you learn things, and then you take those things and you turn them around and you try to industrialize them. And not everybody's going to do the same thing. I mean, we were partners in the research. We were doing the industrialization. We were trying to figure out what came from this project. What did these people learn that we can make use of? And I mean, it's very useful, a lot of that stuff.
Yeah.
It's more useful than a lot of papers that get written, in fact.
That's true. Of recent years, I suppose I shouldn't. It would be a sensitive subject, taking the conversation in that direction. I won't do that. And I think you probably know what I'm going to talk about.
No, I mean, it's all right if you wish.
No, oh, yeah. Caleb, thank you very much. I really appreciate this conversation. I think you've done wonders for the networking world. Like you've set it, even from my perspective, you set a really good example for me. I'll never forget that feeling of my packet arriving in New Zealand via CJDNS. I will never forget that. And it's when you play Quake 1 was my moment, right, when you're like, oh my God, computers can do that, But that was my sort of like one of my moments of, at least in the networking world. And it would be wonderful. I'm going to follow your project, track it and see how it goes, and might even participate in it. And
you should mine some. It doesn't cost you anything. You use your bandwidth to mine. You just fire up a computer and just mine it. It's fun. It's be in the community. It's a cool thing to do.
Really?
Yeah.
Because I got my little lightning network thing going over here. I'm sure I can repurpose it. What's the? It's all Rust.
The packet crypt is Rust, and you just install the packet wallet, and then you get the packet crypt going, and you just use some CPU and some bandwidth, and you're off to the races. That's one of the points of Packet, is to be very low barrier of entry. You should be able to. Everybody should be able to mine. Everybody should be able to be part of that community and that ecosystem, that stuff happening. You can also participate on the network steward side. You're building a network protocol. That could be an interesting thing. Maybe Michael is more interested to evaluate your project in the context of the rules for the packet network rather than the rules of the NGI. there's lots of ways, and it's important for Packet that we continue to finance the build out of the roadmap and mesh networking and research and development on this in general. So there's a lot of opportunities from just mining, packet holding, building some of the tech, building some of your own tech, doing the research, writing even papers. There's all kinds of things that can be done in this community.
How about that? And maybe we could think of that. I don't know if Copernica would. You mentioned that you thought CJDNS was, you said you were being a bit cowardly, right? In the sense that you like the idea of content centric, but the whole shift of the middle west, the center west, would be you feel too much, right?
Let's be cowardly because we can get things done. That's the concept.
No, I understand that. So I would have imagined that something like Copernica would be too dramatic, too ambitious.
Oh, but they can live together. And in fact, they benefit each other, because putting a price on bandwidth between any place and any other place has the effect of establishing what it's worth to cache data in a locality nearby to where it's going to be used. And once you've established that value, then being able to store data with somebody, that's where you're able to, that becomes something that you can put a price on it.
Yeah. That one's a tough one, though. That's a tough one. But because in this sort of like an information-centric network, what happens is you reduce the cost of bandwidth to a theoretical minimum. Because I no longer have to go across the world to go and get this video. I get it from my next door neighbor, whoever's closest, and I get it.
Yeah.
So
they're already doing that, so that's already a smart thing to do. I mean, you've got Akamai and Netflix and all these CDNs.
Nah, they can't get into the living room. Do you see what I mean?
You're right. But the fact that they're doing it in some context shows you that the economics is there.
I see what you mean. Yes. Oh no, very much so. Very so. Definitely. And these are very. These are big companies. They command a lot of money, a lot of value. So I think that some people were saying just make this into a CDN kind of thing. Anyway, I'll see.
Indeed.
This conversation has been fantastic. I really appreciate it.
Oh yeah,
and
me too.
If you have any, do you have any way? If people want to get hold of you and get in contact with you, how should they do that?
Get on pkt.chat, .chat. It's one of these cool domains. It's pkt.chat, and talk to both of us actually, because we're both on there.
Brilliant, mate. Okay, thanks so much.